size get filmed. And they do kind of a peek of it, so he'll just be filming us today. Ignore him. Don't worry about it. It's all good. So today we're going to be talking about reserve design that we've been going over in lecture already. The basics of reserve design I'm not going to touch on much. Assuming that you're all familiar with the concepts that we covered in lecture, and we're really going to be focusing on a systematic conservation planning. So conservation planning is looking across the landscape and trying to create optimal solutions. To do this, the main program that's used is called MarkSan. There's also another extension called MarkSan with zones. And this kind of combines ecological, social, economic data layers, all this different stuff to select areas that maximize their conservation goals at a minimized cost. It's heavily user input dependent, as most of these programs we use. The conservation features of interest all need to be defined by the user as to the cost of protecting those features. You can use coarse filters like vegetation or habitat types, or these fine filters that we went over in lecture like actual species distributions to get at conservation goals. And then within this, we have to set targets for conservation features. We can think about this in terms of a minimum viable population of species, like a certain size, or just conserving a certain percentage of all vegetation or habitat type, keeping it above that. And then in order to examine these, we need to look at, rather than the whole landscape, we examine things unit by unit. So we break the landscape up into a grid or hexagonal cells, as we're working with today, and then you look at what is the best combination of these cells that can preserve the most species. And that's how these reserve design algorithms work. And the algorithm that we'll be working with today mostly is simulated annealing via something called the objective function, which is how MarkSan calculates this kind of optimal reserve. And again, this kind of tries to maximize the number of features that are protected while minimizing the cost. So this is the objective function, this equation at the top here. There are three parts to it, and the goal of any reserve, or the optimal reserve, will be the system of planning units that are selected that result in the lowest possible objective function. So you want to minimize each of these three terms in the equation up here. So this first term, the cost of the planning units, is pretty straightforward. This is just the sum cost of buying each planning unit. So often this is just termed as sort of area, but you could also include things like the actual cost of a given parcel of land in it. The second term is